Hello, I'm Anna Mackay and this video is called Geometric Sequences. So let's consider the following sequences. Looking at this sequence of numbers, 4, 12, 36, 108. Having a think about how they're connected or how you might go from one term to the next. So you'll probably notice that to go from the first term to the second, from 4 to 12, you multiply through by 3. And check to see if that's the right thing to do to move from term to term. And yes, it is. To check this is what we call the common ratio, is you take the two terms and divide them by each other. So you take the second one along and divide that by the previous term. So 12 divided by 4 will give you the same as 36 divided by 12, and so on, to give you 3 each time. And we call this the common ratio. It's going to have a value, we're going to define it by R. Let's look at another one. You might be skeptical at first because you see positive and negative numbers, but you do the same technique with dividing through. And well, you'll notice that it's a multiple of -2 each time, hence the alternating positive and negative signs. The common ratio in this case is -2. Okay. I guess we're ultimately heading towards being able to work out any term in the sequence. So we've got the first 4 terms here, but what if I wanted the 50th term, for example? How could I work that out? Up until now, we've been using each term to work out the one next to it. But what if you don't have that? Well, work out, the one next to it. Okay, so if our first term is 4, our second term is you took the first term, which was 4, and did what to it? You multiplied by 3, and that's how you got to 12. The third term, how did we get 36? Well, we took the second term, which was 12, and multiplied it by 3. And then the fourth term, you take the third term and multiply that by 3. So that's the common ratio each time. But that relies on knowing the previous term. So the recursive formula here for t equals n plus 1. So thinking, I guess, if this was the t(nth) term, then the term after that is the n plus 1th term. To be able to work that out, you had to take the tn term and multiply that by 3. So that's called the recursive formula. And we must define our initial term, our t1 term of 4. Because otherwise you could have any set of numbers multiplied through by 3. You might start at 1. Well, no, let's use perhaps, you could have 2, multiply that by 3, you'd get 6. Then what did it have? 6 times by 3 is 18. And so that's a completely different sequence of numbers. But if we define our initial term, then it will be this set of sequence of numbers that we're after. Now, looking at it in a different way, thinking of these as our 4 terms, T1, 2, 3, 4, that should be fine. Thinking about term 2 here, we had our first term, which was 4, and we multiplied that by 3. Yep, that's fine. Now, to get term 3, a way of thinking about term 3 without using term 2 was it was 4, which was here, times by 3 times by 3 to get to 36. Another way of thinking about that, it was 4 multiplied by 2 lots of 3. So 3 squared in this case. 2 lots of 3. You know what I mean? I don't mean 6, I mean 9. So the fourth term, without using term 3 to calculate that, it was 4. Trying to notice that connection where that 4 came from, multiplied by 3 squared and then another 3. So we would have 4 multiplied by 3 cubed. Having a think about now that power 3 and its connection to the subscript 4 there. Does your connection of what you've decided, how they're connected, match going back previous ones? So we had power of 2 there for the third term. So our explicit formula or general term formula that you can define any term in this sequence is 4, think about what you recognize that as, our first term, multiplied by 3 to the power of n take 1. As we had, if we were after term 4 here, and our n is equal to 4, then that 3 there is n take away 1, 4 subtract 1 to give us that 3. And that's how we calculate that formula. So we could write it in two different ways, the general term formula or the recursive formula. T1 is 4, and that's really important that we often have to define that initial term. R, what was that? What did that stand for again? The common ratio. What was it in this case? 3. When we use the recursive formula, we must state that initial term of 4, and you'll notice that the R, that common ratio, factors into the formula here. I guess as the coefficient of the nth term. Right. Was there anything else there that I needed? No. So they're the two definitions here. Moving on. Okay, an example. Considering this sequence of numbers, show that it's geometric. How might you show a set of numbers is geometric? What might you need to identify? I'm hoping you're going to say the common ratio and the initial term. So looking at the common ratio here, that's where you took subsequent terms and divided them. And you see if that common ratio is the same each time. So we had 4 divided by 8 to give us a half. Next we'll do 2 divided by 4. Yes, giving us a half again. 1 divided by 2, and then that is obviously a half, and then a half divided by 1 to give us a half. So our common ratio must be a half. And so yes, we've confirmed that it is geometric, and we're identifying that the first term is 8. Part B, find the general term. So casting your mind back to the formula that we need for the general term of Tn. That is defined as the first term multiplied by R, the ratio, to the power of n take 1. So let's substitute in the values that we know here. T1 is 8. Our common ratio is a half, all to the power of n take 1. So that's how you work out any term in the sequence. Just a little bit of practice here of rewriting this formula using powers of 2. Occasionally you may be asked to write it in this way. So noticing that 8 is 2 to the power of 3, and this a half is 2 to the power of negative 1. Now let's expand out this bracket. We have, so negative 1 times by n and negative 1 times by negative 1. Simplifying that a little bit more, we have the same base, so we can add the powers, and tidying that up, we would get 2 to the power of n take 4, another way of writing it. And the last part is hence find the 12th term as a fraction. So that means our n is going to be 12, and we substitute that in to either version of our formula. Where we see an n, we're going to put a 12. Let's see how we write that out. We have 12, subtract 1 gives us the 11. Calculating that, we have 1 divided by 256. Good. If you like this video, give it a thumbs up and subscribe to the channel. And the next video in this series is the second part of this geometric sequences section. Thank you.